Bismillahirrahmanirrahim. Assalamu alaikum everyone. We are going to conduct the fourth tutorial on the basics of the MATLAB. Today I'm going to explain you how to generate the vectors in MATLAB environment. Before we go and start our tutorial, I need to explain one more important stuff. You see this current directory or the current folder. This sometimes seems awkward because we do not want to see it all the time. So there is one option available by which you can actually minimize it. And how you do it, it is very easy. Just click on this arrow and you will find there is a minimize option and just click on it. So now your current directory, which was shown, it was actually covering some space of your screen, which is not good if you are analyzing all the vectors, all the matrices. So it's now gone. And we have now only two windows, the command window and the workspace. And these two are kind of integral windows or very important, and we want to visualize all the time. That is why I will not minimize it, but there is an option available. If you want to minimize, you can also minimize your workspace. So that's it. Let's start our video tutorial, and now it will be comfortable environment, more comfortable. So in this video tutorial, I'm going to explain you how one can generate the vectors in MATLAB environment. I've already done that thing in the last video tutorial where I actually explained what is the row vector and the column vector. But today there are numerous ways in MATLAB by which you can generate vectors, and some of them are quite important and some of them are useful in different scenario. So I want to explain all of them in one video. So it will be very detailed video for vector generation. Let's say I want to generate a vector and that vector will have elements in continuous range. For example, the values will start from 2 and it will have 4, 6, 8, and it will go to 10, right? Or you can also say that values will start from 1, it will take 2, 3, 4, 5. So what is the similarity between these two vectors? They are actually defined in one go or in one range or in continuous range, right? Continuous will be the more appropriate word. So let's say this variable is basically C. So I want to define a row vector C with having elements 1, 2, 3, 4, 5. So very easy way to do that. It's very simple. C equals to, and we need to write 1 colon 5. So what I've written, C equals to 1, the starting element of the vector and the ending element of the vector, and between these two elements I need to enter colon and just press enter. You will notice that a vector C is defined or initiated in the memory space. In workspace you can also visualize it. I hope you can see that this C vector is defined. Its values are 1, 2, 3, 4, 5, and it is also shown here 1, 2, 3, 4, 5. It is a row vector, right? So how we did it, we actually used colon command. There is a special command as well. Instead of using this colon operator, you can simply write colon and you will say 2, 5. So your let's say this is basically C, or let's make it D because I want to visualize the two different vectors. Earlier we used this colon operator and now I'm using this colon command. So D equals to colon 2, 5, and I'm going to enter it, and you see that result is 2, 3, 4, 5 because the starting element is basically 2 and the ending element is 5. So this is the one way by which you can actually generate row vectors, right? There is one thing which you can also add up here. Let's say I want to make a matrix E and or a row vector E, and it will be generated using the colon command, and it will be started from 4 and it will go to 20, right? If I'm going to enter, what is going to happen? There are numbers generated or column generated which start from 4, 5, 6, 7, 8. These are in continuous range and values are till 20. But I can actually define the space between the consecutive two elements as well. So let's say 4, 20, but I want to have a space of 2 between the two consecutive elements. So element would be this time 4, 2, sorry, 4, with a space of 2, it will become 6, space of 2, it will become 8, and so on. So this time it is 4, 6, 8, 10, 12, 14, 16, 18, and 20. So this is one good way to generate row vectors. So I hope you understand it. And we can also use the same thing in column operator. And how would you do it? Let's say I want to define a vector A is equals to 4 colon, and let's say I want to have a space of 2, and we want to go to 20 and press enter. So you see result is same. Either you use the colon operator or the colon command, you can actually generate the continuous range vectors or the row vector, right? Sometimes you have to generate some numbers or some elements between the two numbers, right? So for that command, for that purpose, you have another command which is linespace. Let me first of all clear the screen. It will make things more easier to understand. So we have already done one important way, which is colon command, or alternatively, you can also use colon operator. Now there is a third way, or the second way if you consider them in one. So what is that way? That is basically a line command. And how would you do it? Let me show you. The third way is line space, or it should be line space, right? And that is basically starting element and ending element. Starting an element is an ending element, right? So let's see if it works clearly or not. Let's say we have a variable x or a vector which will be generated between the 2 to 10. So line space 2 comma 10. Okay, it's a huge data. I mean, these are basically different values. There's a huge number of values. Let me clear it and let me explain some concept here that it will be easier to understand it. Let's say it is, let's say I'm gonna generate a vector c equals to starting from 2 and it goes to 5, and we press. So we have how many columns? 2, 3, 4, 5. They are easily come up in one line. It's quite easy to represent for MATLAB in one line. But if vector was something like that, 2, let's say starting from 2 and going to 100, or let's say going to 25, let's see what is going to happen. If you're noticing it, the vector is generated, but very important stuff is going on here. Vector is generated and it's basically starting element is 2, 3, 4, 5 as expected, and final element is 24. But there are more than 20 columns, and this MATLAB screen having set these smaller values in one element, only 20 columns can be shown in one row, right? If you are noticing it, it is clearly observable here. You see this is one line and numbers are shown from 2 to 21, and they are basically column 1 through column 20. But in total, there are 24 columns. So column 21 and 24, from column 21 to 24 is shown from the next on the next line. So that is what MATLAB does whenever your number of columns in a row vector is too much or cannot be expressed in one line. So it will take it will divide in 20 columns version, right? Or divide in several columns, right? Or several lines, right? So that is what happening earlier. Let me clear the screen and it will make much more easier to understand. Okay, let's do this CLC. Now I'm going to write, let's say vector x equals to line space, and I'm going to start from, let's say, 2 to 10, right? So there will be numbers generated linearly spaced between 2 and 10, because starting element, as I explained you earlier, is 2 and the ending element is 10. But what is going to happen? How many numbers will be generated? Actually, it will generate 100 elements. 100 elements means there will be 100 columns. So in MATLAB, it won't be easy to represent all of them in one row. So what is going to happen? We will be shown several number of columns. Let's observe this output, and now it will be much more easily understandable. Because output is too large, so it is having multiple rows, but you can actually visualize here column 1 through 12, column 13 to 24, column 25 to 36. So values are generated, right? But they are not in one line because there are huge data. So in total, there are 100 columns, and I can also confirm it using the size command. Let's say I'm going to write CLC. It will clear the stuff. And I'm going to write, let's say, size of X. Remember, X was the vector, X was the row vector which we defined. And if we write, so it says only one row because it is a row vector, but it has 100 columns, which means 100 columns will be shown, and they cannot be shown in single line. So that is why MATLAB has splitted them into several number of lines. By default, line space is producing 100 elements, but sometimes we don't need 100 elements. We have to define 5 elements, 10 elements, 12 elements as per our need. So you can actually modify it. Like say I'm assuming Y, and this time I'm going to produce line space, and it will be, let's say, 2 to 20 as we did in the last time. But let's say I need only 10 elements. So I'm going to write 10. Remember, this syntax is now changed. Line space, starting element, comma, ending element, and the number of elements, which is normally known as n, right? If you're gonna write in MATLAB, I want to visualize this thing in MATLAB because MATLAB shows this clearly. Let's say I'm gonna write Y equals to line space. Last time it was X, so I'm making it Y just to make the differentiation. Line space, and we will start from 2 to 20, but last time it was like of 100 elements, right? Because we did not mention. And if you are observing it here, MATLAB shows it. Line space x1 comma x2, which means it will generate 100 elements that they will be linearly spaced between x1 and x2, right? So x1 is the starting element and x2 is the ending element. While there is another version of syntax which says x1 comma x2 comma n, where n indicates the number of elements that we want to be produced between the two numbers x1 and x2. And here in this example, what I'm assuming, x1 is 2 and x2 is 20, and I'm gonna say I need only 10 elements, right? So you can see that it generates linearly spaced data from 2 to 20, and the space between the two consecutive elements is almost same, right? It's a linearly space. That is why this line is known as line space or the linear space, right? Let's take one more example. It will clear the stuff further. Let's say z equals to line space or line space, right? And we started from, let's say, 2 comma 10. So starting element is 2, ending element is 10, and we need only 3 elements. So this time it will produce 3 elements, including 2 and 10. And you see that 2, 6, 10. And again, the space is same. 6 minus 2, 4, and 10 minus 6 is 4. So space between the two consecutive elements is same. So it is called linearly spaced vectors, right? Just one example, and then we will have some new concept. Let's say W is equal to line space. We started from, let's say, 3, and we goes to, let's say, 25, and let's say we want to have 6 elements, or let's say we want to have 7 elements, right? I just want to use the different values so that it will become easier to understand. So you see that 3 starting element, ending element is 25, and the space between the 3 consecutive elements, total element, first of all, let me count: 3, 6, 0.6, 2, 3, 4, 5, 6. So total overall elements are 7. And you can also do it size of W. It says 1, 7. So one more concept that I want to explain here. Before I explain, I want to just clear some stuff from the screen so that it become more easy to understand. Let's say when I'm going to use the CLC command, it will make things more easy. CLC. Okay, this is not raised, so let me raise it. Yeah, okay, this is also not needed here now, so we will remove it. Okay, and okay, let me also arrange these. This is what we have done. This is we have also done now, and this is also kind of done. So let's say I'm gonna show you. Let's say X. Remember, it was 100 elements. It's not good to show them, but I visualize it using the size command. Size of X. It says 1,100, right? Let's say Y. Size of Y. Remember, we produced 10 elements only. So 1,10 or 110, right? Or Z. Z has only 3 elements. We use size of Z and it says 1,3. So everything is quite understandable. But in row vectors, what do you notice? It's quite important. For X, let me put it a bit higher. For X, it is 100 because the row number is 1. For Y, it is 110, so row number is 1. And for Z, it's 1,3 because it's row vector. So basically, row number will always be 1. So that's why your row number or the dimension of row is insignificant. So that is why we will introduce you with another command, which is known as the length, right? Let me write it for you. Let's say CLC. First of all, I'm going to show you size of X, which is 100. But I can write simply, instead of write size, we can simply write length of X. So it will show you 100 elements because there are 100 elements or 100 columns in X. Similarly, instead of writing size of Y, which will give me 1,10, we can simply write length of Y. It will give us 10, which is the length of the Y, right? Similarly, if I write length of Z, so it will give me 3 because the length of or the number of columns present in the Z vector is basically 3. So that is why the new thing that we learned here, let me add it here, it's more important, length. Length command always return what? The length of the vector. This is very useful command and we will be using it frequently in coming tutorial to understand the vectors and matrices more easily, right? So let me clear that. That's it from this video tutorial. If I summarize, I actually explained in this video tutorial about the colon operator, the colon command, linespace command for vector generation. I hope I have explained it clearly. If you have any confusion, you can post your queries in comment section. Thank you so much for listening.